Now let's talk about how we deal with radians on the x-axis. We've been doing degrees, and because degrees are kind of easier to start out with, but it's a lot more useful to use radians when we're dealing with sinusoidal functions, because radians, unlike degrees, can represent any quantity on the x-axis. They can represent time or distance. So they're very much more useful than degrees. But we don't like the fractions of pi. They're not intuitive. They don't work well with real life. So how do we get from fractions of pi, the fact that our cycle is exactly 2 pi units long, or the period is 2 pi, how do we get to that into real numbers like this, where we just numbered 1 through 10, which would be a lot handier? Okay, so let's see, how do we get from 2 pi as a period to 1 as a period? So what I want you to think about is that 2 pi is about 6.28 radians. So when I go from a period of 2 pi, so I'm just going to write this down, period equals 2 pi, or about 6.28, and I'm using a cosine graph as an example, so from high point to high point is 1 period, and I want to change that, so now I have the period equal to 1, which means I'm making the period smaller. Now, if I wanted to go from 2 pi to 1 pi, I know that would be half as big, so I would have to multiply by 2 inside the function. Okay, so we learned that in this one up here, that if I want to make the period half as wide, I would multiply by 2. So 2 pi to start with, and I multiplied by 2 inside the function, then I would have a period of pi. But I want to get down to just a period of 1. I want to go from a period of 6.28, or 2 pi, to a period of 1. So I'm going to have to basically divide the period by 2 pi to get it equal to 1. Well, we know that we do the opposite of what's inside the function. So if I were to, well, write this as g of x, we'll call this a different function. G of x is equal to cosine of something times x. I have to multiply by the number that I want to divide by. In other words, if I want to make the period smaller, I've got to multiply by that number that I want to divide the period by. I want to divide the period by 2 pi, so I'm going to write in cosine of 2 pi x. That's going to get me from a period of 2 pi, or 6.28, to a period of 1. So let's double check this on Desmos and see how this works. So if we go to Desmos, here's a cosine graph, here's my key points at 0, pi over 2, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. Now let's add another equation in. Let's change this now to y equals cosine of 2 pi x. So I'm going to turn this one off. What do you notice about the period of the function? High point, 0, 1, 0.250, 0.5, negative 1, 0.750, 1, 1. One complete cycle in 1 unit. So we've gone from a period now of 2 pi to a period of 1. So the next step, so what happens, this number right here divides the period by 2 pi. So now we end up with a period equal to 1. Now we want a period of 10. We want to go from a period of 1 to a period of 10. In other words, we want to make our second graph 10 times wider. So to do that, we have to think about what we did in this example above. To make the graph 2 times wider, the period 2 times wider, we multiplied by 1/2, or we could think of that as dividing by 2. So here, to make the period 10 times wider, we're going to have to multiply the previous, inside the function of the previous graph, by 1/10, or divide by 10. So in other words, to get this graph, and I'll call this h of x, is equal to cosine of 2 pi divided by 10 x. So let's double check this on Desmos. Oops, that's not what I meant to do. Desmos. So we'll put a third graph in here, and I'm going to have to probably expand this over to see it, but y equals cosine of 2 pi divided by 10 times x. All right, well this is looking promising. So let's expand this the x-axis so we can see this better. Okay, so I'm going to go over here and turn off this graph. Well, I can just look at the big graph. No, I'd like to turn off the other graph. I've got to figure out where to do this. Okay, turn off this graph and we'll just look at the new graph now. So here's our new graph. Starts out at 0, 1. Notice it ends at, or it starts at 0, 1, it ends at 10, 1. Its halfway point is at 5, 1. A fourth of the way through the cycle is 2.50 and 7.50. So we have successfully taken a graph that had a period of 2 pi and changed it to a graph that has a period of 10, which is much more useful for real-life problems. So notice, in order to make the graph, the x-axis look simpler, we had to make we had to include pi in the equation, because we had to divide by pi to get rid of pi. Or sorry, we had to multiply by pi to divide the pi out of the original function. Then the denominator tells us our new period. So multiplying by 2 pi reduces the period to 1, dividing by 10 then gives us our new period of 10. Now, typically when we write these in problems, we will write it as cosine of pi over 5x, where 5 is equal to half the period. You can do it either way, but pi over 5 is typically the way you'll see it. So this now has a period equal to 10 units. So when we divided, this made the period, this part right here, made the period 10 times wider. So we're going to look and see how that works then in putting all of these pieces together. We've done 4 different transformations. How does that work in a general equation?